not finished until we do what though? Dx. And so our antiderivative is actually, this would give us the slope of those tangent lines, and the antiderivative is going to be the same. I'm sorry, the derivative is going to be the same for each of those, regardless of that constant term, because we get what we call parallel graphs. Okay. Now, this is a little different question. It says solve the differential equation. I don't think I have the homework for this section ready for you. It's not posted on WebAssign yet, so you've got a little bit of time to kind of mull this over. But when we say solve the differential equation, what we're saying is you're given a second derivative, you're given the first derivative. The question is, what is the function that would yield this second derivative and have this first derivative value when the input is 0? That's what we say by solving the differential equation. Okay, I do want to talk about that one problem. So we're gonna stop this for now, and let's look at. I'm gonna just insert a page here. Chelsea, the problem you were given was. Okay. But the one that you and I worked on was the limit as x goes to infinity. Okay, have you run across a problem like that in WebAssign? Section 4.5. Okay, let's talk about this, because I can't remember, that section homework is due on the 19th. What is the day? The 16th? We got 3 more days. Let me just kind of help you through this a little bit. 2 hints. First one is, go back to chapter 2. We talked about this, I think, before. Back to chapter 2, there's a theorem back there. I don't know the number of it, but it says that the limit as x approaches 0 of sine x divided by x is equal to 1. Okay, that's the first hint. So if we can get this problem into this format, we're okay. Second hint, so that's the first hint. Second hint is, let x equal 1 divided by t, and this is what Molly found on one of the hints that was given to her for the problem, and look at the limit as t goes to 0. I'll say of f of t. Okay, now, if you have x going to infinity, and you let x be 1 divided by t, then as x goes to infinity, well, as t goes to 0, x would be going to infinity. If you divide by, remember that little thing about, I've got these dots and circle groups of nothingness? Okay, your idea is that you have infinitely many groups of nothingness to do, and so if t goes to 0, x is going to infinity. Okay, so those are the 2 hints. Now, beyond that, what we have is, so this will be the limit as t goes to 0 of 3 times 1 divided by t times the tangent of 8 divided by 1 divided by t. Now, if we can get it into a situation where you have the sine of this quantity divided by that same quantity, you've got the limit equal to 1 of that piece. Now the question is, you can't just arbitrarily start dividing in here. That's not allowed. Okay, but what we do have is the limit as t goes to 0 of 3 times the tangent of 8 divided by 1 divided by t divided by 1 divided by t. Now remember, this is only going to work for sine. We don't have sine, we have tangent, but can we get sine out of that? Can we change tangent so that sine is there? Okay. The other thing is, I've got 8 divided by 1 divided by t. I only have 1 divided by t here. So what do I need on the sine part of it in order to use this? This has to be 8 divided by t, or 8 divided by 1 divided by t. Let's do this. Let's do the limit as t goes to 0 of 3 times the tangent of, what is 8 divided by 1 divided by t? 8t. Divided by, well, if I divide by a fraction, that's the same thing as multiplying with the reciprocal. Okay, so now I've got the limit as t goes to 0 of 3t times the tangent of 8t. Again, you can take tangent to be sine divided by cosine. When I'm looking at sine, though, I've got to be sure that I have this situation set up. If I can make this sine divided by cosine, I'd have sine of 8t divided by cosine of 8t. What do I need in that numerator of sine of 8t in order to use this? I need a fraction. I don't want to tell you everything, okay? But let me remind you that if you multiply by a factor of 1, you haven't changed the value at all. So I could use that as maybe 8t divided by 8t, and that's all the farther I'm going to go on that. Okay? Okay. Now, you guys came in to do the extra credit. Okay, be with you in about 2 minutes now. Anyone in here going to stay and do extra credit? I will keep it open for Thursday. Okay? I think I say that I need to have it done by the 3:30 on Thursday. So yes, you can do it on Thursday.